Welcome to the Beginner's Guide to Composites. By the end of this video series, you should have all the knowledge and tools that you need to start your very first carbon fiber or fiberglass project. And it all starts right here. This is carbon fiber tow. What this is this is a bundle of individual carbon fiber strands. This is 12K tow, meaning that there are 12,000 strands of carbon fiber in this little strand of tow. It's incredibly strong in tension. You could literally lift up a linebacker with this one little strand. But in compression, it's like trying to push a rope. You can't actually carry any compressive loads with this, only tension. That's where the resin comes in. What the resin does is it actually stiffens this so it can take compression loads. It's kind of like that one time when you put super glue in your pocket, when you forgot about it and sat down, you turned your pants into a piece of cardboard. Yeah, I did that. Well, it works the same way with this. It's almost like paper mache too. Think about paper mache, you get the paper wet with the paper mache. Once it dries, it hardens, it turns into a shell. That's the same thing that we're doing with this, and that's what makes it a composite. You're mixing two different materials to make something completely new. Now, if you were to take a whole bunch of these and put them together, you get what's called a unidirectional fabric. You can see this is made up of individual tows that have been laid side by side, and on the back you can see there's a little bit of a binder that's been used to hold them together. It's unidirectional because the fibers all run in one direction. Unidirectional is generally the strongest type of fabric that you can use because all the fibers are going the exact same direction. And it's the easiest way to align the stresses with the fibers, which is the strongest direction. Carbon fiber is strongest in the direction of the fibers. It's not very strong in the other direction. Now, if instead you were to weave those fibers together, you'd get something like this. This is a woven fabric. And you can see that this is made up of individual pieces of tow. This right here is a 3K tow. In other words, there's 3,000 strands of carbon fiber in this bundle. Sometimes a woven fabric like this is also called a biaxial fabric or a bidirectional fabric because there are fibers going in two different directions. This is what's called a plane weave. If you look very carefully at the fibers, you'll see that each tow goes over one and under one, over one and under one. Conversely, you can have what's called a twill weave. I'll put these side by side so you can compare. And instead of having each bundle go over one and under one, over here you can actually, if you look closely, you'll see that it goes over two bundles and then under two bundles. And it gives it a very different look. Now, why would you want that? There are a couple of reasons why it's helpful. One is that this fabric actually is easier to manipulate and it conforms better to curves. It has what's called good drape properties because it drapes into the mold nicely. Whereas the plane weave doesn't conform quite as nicely. Still pretty good though. The other reason that people choose a twill weave is just for the look of it. It looks kind of cool. You can see the difference. If you like it better, then you can choose this one. Another thing I'd like to point out about these is that this is a much heavier fabric. If I were to actually put a micrometer on this, you could measure it, and it's about twice the thickness of this one. That's because this is made of 12K tows. So each bundle has 4 times as many fibers in it as this one does. So it ends up being a much thicker fabric. This lighter fabric is actually 5.8 ounces per square yard. So if you had 1 square yard of this fabric, it would weigh 5.8 ounces dry before you put resin in it. This one over here is about 12 ounces per square yard, much, much heavier. So obviously if you're building up a part, you need half as many plies of this one as you would of this one. In my experience, you'll see more of this weight fabric than anything else, 5.8 to 6 ounces per square yard. That's the most common, and it's about 10,000ths of an inch thick per ply. The weight of fabric you'll often see in GSM as well. GSM in ounces per square yard are the same thing with just a conversion factor in between. GSM stands for grams per square meter. Another term you'll see thrown around a lot is high modulus fabric. And what that means is that it's stiffer than the others. Not necessarily stronger, but stiffer. So for a given force applied to it, it'll stretch less than a lower modulus fabric would. High modulus fabrics are usually more expensive, and unless you really need it for your application, I generally avoid them. I'll make sure I put a link to the kind of fabric that I use in my shop, and you can actually go buy it there. Now, other materials you might find yourself using include Aramid, commonly known as Kevlar, and fiberglass. Fiberglass is particularly useful because it is very, very inexpensive compared to carbon fiber or Kevlar. However, it is definitely not as strong. So if you're looking for the maximum strength to weight ratio for your part, fiberglass isn't the choice. You're going to definitely want to go with carbon fiber for that. Carbon fiber is also the stiffest of the three. However, it is the most expensive. I like to use fiberglass especially for building up molds because it is cheap, and then I'll use carbon fiber for the actual part. Kevlar is kind of a unique one. It's somewhere in between the two in terms of strength and stiffness. However, where it really shines is in its toughness. It takes impact much better than the other two do. So if you're looking for something that's very abrasion resistant, Kevlar might be the best choice. Just remember, Kevlar is a bear to work with. To give you an example of how difficult it is to work with, fiberglass and Kevlar cut really easily with just a pair of scissors. Kevlar, on the other hand, does not. I can try and cut it and it just does not want to cut. It'll push the fibers around a little bit, but it does not want to cut. And if it's bad with a pair of scissors when it's dry, when it's cured it's 10 times worse. With the other two, when they're cured, you can use an abrasive disc like a Dremel tool to cut them. Whereas if you cut Kevlar that way, it's going to turn into a big fuzzy mess. So I avoid Kevlar if I can, and if I am using it, I'm going to try and make sure that the edge is inside of where I have to trim the part so I don't have to actually cut through the Kevlar afterwards. Now they make specialty scissors just for cutting Kevlar, and they do work quite well. However, I learned a trick a long time ago, where if you take your scissors, and if you just gently run that edge flat across a disc sander for a second, it roughs up the edge just enough that it'll grip the fabric and it'll cut it a lot better. But again, you don't need to do that for carbon fiber or fiberglass. All right, let's talk about resins. Now, there are two primary categories of resins that you're going to see. There's your vinyl ester resins and there's your epoxy resins. Both of them work for making composite parts. However, one is far superior to the other in terms of strength and workability, and that's the epoxy. Every part that I make with epoxy resin. I don't even keep vinyl ester in my shop. Yeah, it's a little bit cheaper than epoxy, but the difference in strength and performance is vast. And it's really worth it to just fork over a little extra money and get the epoxy. And the resin that I use in my shop is Resin Research Composite Pro 2050. There are a lot of really good resins out there, but there are a few reasons why I like this one in particular. Number one is the cost. It's one of the least expensive resins that I know, and yet it still delivers really, really high strength parts. Yes, the resin does affect the strength of your final part, and this is a pretty darn good one. Number two is the workability. It's a very low viscosity resin. It's a lot thinner than some other ones that I've used, which makes it easier to wet out the fibers quickly. It also makes it easier to make lighter parts and keep the resin content of your composite down, so your fiber volume is a lot higher. Stronger, lighter parts is the result. I really like that it's clear. Some of the resins that I've used are almost this nasty amber yellow when they're cured. Doesn't make very pretty parts. This stuff cures very clear. And lastly, and this might be one of the biggest things, is that it's a very, very mild resin in terms of health concerns. It has no odor that I can detect, and it was recommended at first to me by a friend who was having some issues with reactions to different composite resins that he was using. It got to where just being in the same room as an open bottle of the resin, he'd start to have a reaction to it. So he switched to this stuff, and all of a sudden all those problems went away. This is a much milder resin than a lot of the ones you're going to find out there, but it still offers good high performance. One of the terms you're going to see thrown around a lot when you're looking at resins is pot life. Pot life is a measure of how long you have before your resin starts to get thick and unusable. Essentially, it's the working time that you have to finish your part. The Composite Pro system has 3 different hardeners that you can use. There's the slow hardener, the extra slow hardener, which is what I have here, and the fast hardener. The fast hardener has a pot life of about 20 minutes, whereas the extra slow has about 90 minutes of working time before you need to get that stuff in the vacuum bag and done. If you're looking for a really, really fast pot life, I always keep around a little bit of their Quick Kick. It's also a Resin Research product, but it has a much faster hardener. This stuff usually kicks off in about 15 minutes for me, but it still has the high strength that the other stuff does. Because all the parts that I make are small, I'm only working with really small amounts of resin, so I like to keep mine in little squirt bottles. And I take each one and I label it with what it is and what the mix ratio is supposed to be for that particular resin. Just make sure that if you buy some of these squirt bottles, get the ones that are HDPE plastic. You get the wrong plastic and the resin can actually melt through it. That's not a good thing. Keep in mind that once you reach the pot life, the part is not cured. That's just the point where the epoxy starts to turn into kind of a thickened gel. This stuff, to reach a full cure, you're looking at about 6 hours for the fast hardener and about 24 hours for the extra slow. And I'll even usually leave mine in the molds a little bit longer than that, just because for a long time afterwards, you're still going to have some cross-linking of the polymers, and it makes a stronger part if you keep it that way. Keep in mind that different resin systems have different mix ratios. For example, this one, the Composite Pro, is a 3-to-1 mix ratio by volume. So what that means is if you're making a 4-cup mixture, you'd have 3 cups of the resin and 1 cup of the hardener. Now the Quick Kick is a 2-to-1, so you'd have 2 cups of the resin, 1 cup of the hardener. Also keep in mind that if you measure it out by weight, like I like to do, then the ratio might be a little bit different than if you measure it by volume. For example, this is 3:1 by volume, whereas it's actually 10:3 by weight. It's a very small difference, but it's enough to be worried about. Also note that unlike vinyl ester resins, where if you add more hardener, it just cures faster, you can't do that with epoxy. You have to maintain the exact mix ratio that the manufacturer recommends. Otherwise it won't cure properly, and you'll have either a gummy part or a sticky part, and it won't have the strength that it needs to have. I'll put a link below to the manufacturer's website where you can find the information on these resins, and you can actually order them in larger quantities. If you're looking for 1-gallon kits though of the Resin Research Composite Pro, then I'll put a link to where you can get that as well. If a 1-gallon kit is more than you want to invest in right now, another resin that works well is AdTech. You can get that from Solar Composites, and I'll put another link to that one below. I know some of you are probably like, but Brandon, I just want a small amount, just enough that I can try this out. For you guys, check out the link to Gorilla Carbons. They've got composite kits there with the fabric, the resin, all the things that you need, and it's in smaller quantities, and so it's a lot cheaper for you guys who are just looking to try it out. A common question that I get is, but Brandon, do I need to have an oven or an autoclave to cure my composites? The answer is no. This is a room temperature resin, which means it cures at room temperature. As soon as it's mixed, the curing process starts. However, there are elevated temperature resins. Most commonly what you're going to see is a pre-preg. What that stands for is pre-impregnated fabric. These are fabrics that already have the resin inside the fibers, so you don't have to wet it out. And it's almost like taking a vinyl sheet and sticking it down. And then once you've got all your layers down, then you do have to cook that in an oven to get it to cure properly. Even with pre-pregs though, you don't necessarily need to have an autoclave, but keep in mind that autoclaves will give you the best strength to weight ratio. Really all an autoclave is it's a big pressure cooker. Generally it pumps the pressure in the chamber up to about 60 psi while you're pulling vacuum on the part, so all that pressure compacts the layup, which makes it a more efficient structure. It also makes it so it has better strength between the plies so they don't peel apart quite as easily. The other thing that an autoclave does is it adds heat, so you have an elevated temperature cure. Again, for a room temperature resin, you don't necessarily need an elevated temperature for it. Some room temperature resins though, after the part's been cured and pulled out of the mold, you can post-cure it, which is where you put it in an elevated temperature environment, some kind of an oven, after its initial cure. And when you do that and you hold it at a higher temperature for a longer period of time, it can actually strengthen the resin, it actually strengthens the part, and what's more, it makes it more resistant to higher temperatures later on. So if you want your part to not warp when it's sitting out in the sun, it can be useful to post-cure it. Whatever you do, please do not post-cure it in your kitchen oven. It's not safe. It can put out fumes that are not healthy for you to breathe. I don't recommend you do that. If you want to post-cure some parts, you can actually make a pretty simple and effective oven with just some 100-watt light bulbs and a box made out of foam. Let's talk about core materials. First of all, let's talk about why core materials are useful. I want you to go find yourself a ruler, or don't, just watch me play with mine. But if you take the ruler and you bend it this way, it's pretty floppy. But if you turn it vertically, all of a sudden you can't bend it that way very easily at all. It's very, very stiff, very, very strong. So what's going on there? Well, whenever you bend something like that, the material on the outsides is what's doing most of the work. So when you turn it this way, you're spreading that material out more vertically, and it's able to take a lot more load. That's the principle behind putting core in your panels. What you're doing is you're taking a carbon fiber sheet on the bottom and one on the top. The carbon fiber is the strong part. That's what's taking all the loads. All you're doing is you're spreading it out so that it's able to be a lot stronger in bending like this. The alternative would be to make that panel super, super thick with all solid carbon fiber, but that's a lot of weight, and the material in the middle isn't really doing very much. It's not stressed very much, and it's useful to put something that's lightweight, even though it's weaker, in the middle because it's not taking very much stress. The stress is taken entirely by the face sheets because they're the parts that are farthest away from the center. There are two primary families of core materials. There's your foam cores, like this, and there's honeycomb, like this. Each of them comes in their own different flavors, each of them comes in different materials, but for the most part they serve the same purpose. Let's talk about foam materials first. Foam comes in about a bazillion different varieties, made of different materials. There's your polyurethane foams, there's your PVC foams, there's your acrylic foams like Roacell. there are a lot of different options. So how do you choose the one that's best for you? It really does depend on the application. If you're looking for something that requires high temperature tolerance, you need a specific foam that's able to take higher temperature tolerances. If you look at the manufacturer's specifications, it'll tell you exactly what you're looking for. Different materials do have different strength to weight ratios. Roacell is one of the most popular foams because it's actually got a very, very high strength to weight ratio, and it's very, very stiff. The other thing I like about Roacell is that it machines really, really nicely. So if you're trying to make something that's got a complex contour and you want your foam to match that contour, you want to put it in a CNC machine, Roacell cuts better than anything else I've seen. The disadvantage to Roacell is that it's a bit expensive. In this particular thickness and weight, it's about $250 to $300 for a 4-foot by 8-foot sheet. This is Roacell 31, which weighs about 2 pounds per cubic foot. It also comes in 51 and 71, which are just higher densities, so you'll have a heavier piece for the same size. The advantage to going to a higher density foam is that it's going to be stiffer and stronger. This one's Divinycell. It's a lot cheaper, but it doesn't have quite the same strength to weight ratio, and it doesn't come in quite as low of a density. Keep in mind that if it's a very highly loaded panel that you're making, a lighter foam may not be the best option because the strength of the foam does have an impact on the strength of your overall laminate. And if you're looking to go really, really cheap, you can actually get by with just buying blue insulation foam or pink insulation foam from Lowe's or Home Depot. And yeah, you can make a strong panel with just those. The other family of core materials is honeycomb. Honeycomb is used extensively in aerospace because it offers a really good stiffness to weight ratio. Honeycomb also comes in varying densities, from about 3 pounds per cubic foot all the way up to stuff as heavy as 20 pounds per cubic foot and maybe even higher. And once again, the heavier it is, the stronger your laminate's going to be. This particular honeycomb is what's called Nomex. Nomex is made by taking basically a paper, saturating it with a resin, crimping it, and then gluing the little ribbons together to make little honeycomb cells. Just like foam, you can have honeycomb that's made in different materials. The common ones are Nomex, Kevlar, and aluminum. Something else I should bring up is that it's very common to bevel the edges of your core. And here's why. If you have fabric that comes along, makes a 90-degree turn, and then another 90-degree turn, those areas where it's bent, those are essentially stress risers. And it's going to be very hard for the loads that you're applying to it to go up and around that corner. If you have a nice ramp for those loads to go up and over and back down again, it works a lot better. If you think about it, when you lamp apart, you're essentially smearing glue into your mold. And while you want that epoxy, that glue, to stick to your fabric, you do not want it to stick to the mold. That's where release agents come in. Release agents keep your part from sticking to the mold. Release agents come in various types. In my shop, I stick to 2 primary types. There's your wax and your PVA. Wax is probably the most basic type of release agent. It's a lot like waxing a car. In fact, you can even use some car waxes as release agents in your molds. However, I use Pardal number 2 in mine. One of the things I like about wax compared to other release agents is that it actually polishes the mold as you're using it. So you can polish it down to a fairly fine grit, and then you use the wax and it gives it a really, really good shine. To apply my wax to the molds, I use microfiber cloths. You can get these at dollar stores. I get mine at Harbor Freight. You don't need expensive ones, just use cheap ones, and I go through them periodically. As they get saturated with wax, I eventually will replace them with a new one. I keep one in the can that I use to smear the wax onto the mold, and then I use a dry, clean one to buff it back off. In conjunction with wax, I like to use PVA as well. PVA stands for polyvinyl alcohol. What PVA does is it basically provides a chemical barrier between your epoxy and the mold, so that you can't get chemical bonding between the two. Wax provides a really slippery surface, but the PVA keeps the chemicals from bonding together. That's why I like to use the 2 of them together, and I have better luck doing that than I've ever had with just one individually. Some people say that in order to avoid streaks, you really need to spray your PVA into the mold. Maybe it's just because I use smaller molds, but I've had really good luck with just using a brush. I've tried brushing PVA on with a regular horsehair brush or something similar. It leaves streaks, it does, but I found that if you use a foam brush, it works extraordinarily well. I don't get streaks. When you brush it on, sometimes you'll get some little bubbles around the edges in some places, but my experience has been that those bubbles pop as it dries and you get a really smooth glossy surface as long as your mold also has a glossy surface. The brand of PVA that I use is Coverall. It also comes in a green bottle. The green I think is an alcohol-based. This is a water-based. I have had better luck with the water-based for getting a good streak-free finish on my parts. If I can avoid spraying things in my shop, I absolutely will. I'll go to great lengths to make sure I don't put those particles in the air, which contaminate not only your lungs, but they also contaminate any fabrics or anything else that you have in the room. So by avoiding spraying, I avoid having to set up a separate spray booth just for those things. And with release agents, you really don't want to be spraying in a room where you're storing your fabrics. The other family of release agents, which I don't use in my shop, is semi-permanent release agents. That's stuff like Free Coat, or there's another brand called Zyvax. You wipe it on the mold once, and then you don't have to wipe more on until several parts later. They absolutely work. I've used them in commercial applications, but in my home shop, I haven't used them because this is what I have experience with, and it works very, very well for me, so why change it? Just like with PVA, I recommend avoiding spray-on semi-permanent releases. If it comes in an aerosol can, I don't want it in my shop. Let's talk about health and safety. Now, some of you might be tempted to skip over this part. Please, for the sake of your own health, your own safety, and your own long life, please don't do that. Watch this, it's worth your time, I promise you, unless you really like having itchy skin and rashes. Some of you might. For starters, let's talk about resins. Epoxy resins have this interesting characteristic where pretty much everybody will eventually become sensitized to them if they have enough exposure to it. So if you keep getting epoxy on your skin, it may not bother you at first, but over time, after a while, you most likely will develop a sensitivity to it, and then it'll start to get a rash, it might start to itch, it'll start to burn, and you don't want that. So make sure you keep the stuff off your skin. And the most important tool you're going to have for keeping the stuff off of your skin is a good pair of gloves. I use nitrile gloves only in my shop. I don't use latex. I've heard somewhere that latex actually doesn't block the resin from getting through. Some of those toxins still get through to your skin. I don't know if that's true or not, but all of the manufacturers that I've worked at and that I've talked to, they all use nitrile gloves in their own shop. I'm using 5mm nitrile gloves that come from Harbor Freight. They're super reasonably priced, they're thick enough, and they do keep the resin off my fingers, and they work great. I'll be the first to admit that I don't always do this, but I do recommend using safety glasses when you're working with epoxies. If the resin splashes, it gets in your eye, that's a problem, you don't want that. Wear some safety glasses to keep drips and splashes out of your eyes. I recommend it. Like a lot of chemicals, epoxies can emit vapors. Most epoxies have some kind of a smell to them that you can detect. That's part of the reason why I like to use the Resin Research resins, because they have a very, very low toxicity as far as that smell, and I can't smell them at all. That being said, I do still try to make sure I've got a well-ventilated shop so that I'm not breathing the fumes all day. If you're using a stinkier resin or you really want to take extra precautions, it's not a bad idea to go ahead and wear a respirator. And if you're going to wear a respirator, you don't want to have a dust cartridge. You want to make sure it's an organic vapor cartridge. This will block the stuff, that one won't. It's also worth noting that a dust mask like this one is not going to stop those vapors, so don't try this one for that purpose. Please be vigilant. If you start to have issues with breathing at all, stop what you're doing, leave the room, and get the emergency help that you need. And then the last thing with using resins that I'd like to mention is something to protect your arms and your clothes or your front. You can get sleeves that are specific just for that purpose. They're kind of sweaty, they don't breathe very well, but they do keep it off, and they have plastic aprons for that as well. Or you can use like what I use when I'm doing bigger stuff, and I just wear one of these. A full-on bunny suit. Super useful if you're going to do something that's a bigger mess. If you're going to be doing a much bigger layup, you're worried about get splashed on your clothes, on your skin, anywhere, this covers you head to toe. It even has a hood in the back to pull up over your head. Super useful. These only cost about $5 to $8, and I get mine on Amazon. I'll throw a link to where you can buy them in the description. Depending on which release agent you're using, you may not need to take quite the same precautions with those as you need to do with the resins. Still, it's not a bad idea to wear gloves, and it's not a bad idea to wear a respirator, especially if you're spraying. If you're spraying anything, whether it's PVA or a semi-permanent mold release, wear a respirator. It's for your own health. Take care of yourself. You only get one pair of lungs. And of course, take a look at the MSDS sheet, the Material Safety Data Sheet, for any chemical you're using in your shop. Make sure you look at what the manufacturer recommends for your proper safety equipment so that you don't have health issues. It's worth it. Take care of your body. When you're cutting any kind of a fibrous material, whether it's carbon fiber or fiberglass or Kevlar, you want to make sure you've got good protection for your lungs. It's like any dust. It's going to be bad for your lungs for you to breathe it. Now, I've looked at some safety sheets, I've looked at some studies. Nothing that I have found so far has shown that it's any worse than wood dust, but wood dust isn't very good for your lungs either, so make sure you do take care of yourself. At a bare minimum, make sure you've got some safety glasses and a respirator. don't use a cheap respirator. Don't use those cheap ones you can get at the dollar store. Make sure it's a good quality one that seals all the way around. I'll throw a link in the description to one that's actually quite good. This will block out the dust that you need it to block. That being said, it's not a bad idea to use a full face respirator like this one with a dust cartridge. The nice thing about these is that if you got clouds of carbon dust going up in the air, it can't get around your safety glasses and into your eyes because it's sealed all the way around. This really is the best way to go. I recommend it if you can spring for one. The dust from cutting carbon fiber and fiberglass is also pretty itchy to your skin. I've looked and I have yet to find any studies that showed long-term health problems as a result of exposure just to your skin to carbon fiber dust. That being said, it itches like crazy. So do what you can to keep the stuff off your skin. If I'm just doing really light cuts, I may just try to be careful to keep the stuff off my hands. But if I'm using a power tool at all, or if I'm cutting anything bigger, at the very minimum, I'm gonna wear a pair of gloves. And what I really like to do is wear one of those bunny suits as well. And to make sure that you're keeping all of that dust off your skin, I like to wear the full face respirator with the hood over my head to keep my whole face sealed off. And then what I'll do is I'll take masking tape and I'll tape my sleeves to my gloves so that it's sealed and the stuff can't get up into my sleeves that way. Okay, so that's cutting cured laminates. What about just cutting dry fabric and handling dry fabric? Should I be worried about wearing gloves? Well, if you're not wearing gloves while you're handling it, the oils in your fingers can be a contaminant to the material. So it's recommended that if you're going to use that stuff for anything structural, make sure that you're actually going to wear gloves while you're handling the material for that purpose. That being said, it's not really that much of a skin irritant. Yeah, if you plunge your arm into a box full of loose things of carbon fiber raw fabric, then you might get a little bit of itchiness from some of those fibers sticking to your skin. But for the most part, it's not too bad, and it is nowhere near as bad as if you're cutting a cured laminate with an abrasive disc. Alcohol and acetone are very useful for cleaning out drips of wet epoxy. However, that being said, make sure you have really good ventilation in your room if you're going to use those. They don't just stink. You can get yourself into a mess if you fill a room with just those vapors. The other thing with alcohol and acetone is that they are highly flammable. And it turns out so is PVA. So with all of those, keep them away from any open flame sources, any kind of a spark for your own safety. All right, the last thing I want to mention in this section is exotherm. Another interesting property that epoxy has is that it actually creates an exothermic reaction. So the two parts mix together and there's a chemical bonding that's happening between those two, and it releases energy in the form of heat. Well, if you have too much epoxy in one spot at the same time, it can't dissipate that heat fast enough, and it'll actually do what's called, we just call it an exotherm. So if you're ever sitting there doing your layup and you notice your pot of epoxy starts to boil, you should probably take it outside, because not only is that releasing harmful vapors, but it will continue to produce heat and it'll get warmer and warmer. If left long enough, that heat can build up that it can actually catch fire. Once you see an exotherm, it's really hard to stop it. The best things you can do are, first of all, take it outside, put it on top of some kind of a brick or a concrete block, something non-flammable, and just let it finish its course. But the best thing to do is to just notice it early while it's starting to get warm, before it exotherms. If it's just starting to get warm, good idea to go ahead and spread it out into a larger container or spread it out into your layup quickly so that it can dissipate that heat and the exotherm never happens. And that's it. I hope this video has been helpful to you. All the things that were mentioned in this video, you'll see links to down below and on the resources page on the website. Make sure you go check those out. And I look forward to seeing you in my next video, where I'm going to cover some of the different techniques that you use to make carbon fiber and fiberglass parts. See you then.
I am your father.
I feel like the Stay Puft Marshmallow Man.